Hello students, welcome to this lecture on complex numbers and quadratic equations. In this lecture, we will cover NCERT miscellaneous exercise. This is a disclaimer. So first, we will study NCERT miscellaneous exercise questions. So you are with your notebooks and pens ready. And now let's start the lecture. So let's look at this question involving complex numbers. So in this question, we are given x minus iota y equals square root of a minus iota times b divided over c minus iota times d. Then we have to prove that x square plus y square whole square equals to a square plus b square divided by c square plus d square. So first of all, think about this. How would you approach this question and then see solution. So let's start the solution. So we start with the given equation. So we are given x minus iota times y equals square root of a minus iota b divided by c minus iota d. Here x and y are real numbers and a, b, c, d are also real numbers, and our goal is to manipulate this equation to eventually prove the x square plus y square whole square equals to a square plus b square divided over c square plus d square. So let's clearly state what we need to prove. So we have to prove that x square plus y square whole square equals a square plus b square divided by c square plus d square. So by taking the modulus of both sides of the given equation, we get absolute value of x minus iota times y equals absolute value of square root of a minus iota times b divided by c minus iota times d. Remember, the modulus of a complex number tells us its distance from the origin in the complex plane. Now recall that for any complex number z equals u plus iota times b, the modulus z equals square root of u square plus v square. So this is just like finding the length of the vector from the origin to the point u comma v in the complex plane. Also, let's remember two important properties. The modulus of a square root is the square root of the modulus, and the modulus of a quotient is the quotient of the moduli. So modulus of square root of z equals square root of mod z, and modulus of z1 divided by z2 equals modulus of z1 divided by modulus of z2. Applying these properties, we get square root of x square plus minus y whole square equals square root of absolute value of a minus iota times b divided by absolute value of c minus iota times d. Now let's write the modulus of a minus b and c minus d explicitly. So we have square root of x square plus y square equals square root of a square plus minus b whole square divided by square root of c square plus minus d whole square. So simplifying further, we get square root of x square plus y square equals square root of a square plus b square divided by square root of c square plus d square. First, let's square both sides of the equation. On the left we have x. On the left we have square root of x square plus y square whole square, and in the right we have square root of a square plus b square divided by square root of c square plus d square whole square. Now we simplify the equation and we have x square plus y square equals square root of a square plus b square divided by square root of c square plus d square. Next, let's square both sides again to eliminate the square roots. So this gives us x square plus y square whole square equals square root of a square plus b square divided by square root of c square plus d square whole square. Finally, we arrive at our result, that is x square plus y square equals a square plus b square divided by c square plus d square. Okay, so hence proved. Now let's look at question number 5. In this question, we are given z1 equals 2 minus iota and z2 equals 1 plus iota, and then we have to find modulus of z1 plus z2 plus 1 divided by z1 minus z2 plus 1. So first of all, try it yourself and then see solution. So first, let's restate what we are being asked to solve. Okay, so we need to find the modulus of z1 plus z2 plus 1 divided by modulus of z1 minus z2 plus 1, where z1 is 2 minus iota and z2 is 1 plus iota, and we have given that absolute value of z1 plus z2 plus 1 divided by z1 minus z2 plus 1, where z1 is 2 minus iota and z2 is 1 plus iota. So now let's start with the numerator. So here we substitute z1 and z2 into the expression z1 plus z2 plus 1. This gives us 2 minus iota plus 1 plus iota plus 1. Now let's add the real and imaginary parts separately. For the real parts, we have 2 plus 1 plus 1, and for the imaginary parts, we have minus iota plus iota. Notice that the imaginary parts cancel each other out, so the numerator simplifies to 4 plus 0 times iota, which is just 4. This means the numerator is a real number with no imaginary part. Next, let's work with the denominator. So we substitute z1 equals 2 minus iota and z2 equals 1 plus iota. So again, let's be careful with the signs as we combine the terms. So expanding the denominator, so we have 2 minus iota minus 1 minus iota plus 1. Now let's combine the real and imaginary parts in the denominator. For the real parts, 2 minus 1 plus 1, and for imaginary parts, minus iota minus iota. Now simplify the expression. So after combining, we get 2 minus 2 iota. So the denominator is 2 minus 2 iota, which is a complex number with both real and imaginary parts. Now let's look at the expression, what we have to evaluate. Okay, so now the expression becomes absolute value of z1 plus z2 plus 1 divided by z1 minus z2 plus 1 equals 4 divided by 2 minus 2 iota. So further, if you simplify, then the denominator becomes 1 minus iota and numerator will become 2. Okay, and the expression will be become 2 divided by 1 minus iota. To simplify 2 divided by 1 minus iota, we want to get rid of the imaginary part in the denominator. So we do this by multiplying both the numerator and denominator by the conjugate of the denominator, which is 1 plus iota. So we have 2 divided by 1 minus iota times 1 plus iota divided by 1 plus iota, and this is simply equals 2 times 1 plus iota divided by 1 square minus iota square. So now let's expand the denominator. So 1 minus iota times 1 plus iota equals 1 squared minus iota squared, which is 1 minus of minus 1, that is simply equal 2. So our expression becomes 2 times 1 plus iota divided by 2. So our expression will become 1 plus iota. So now we have the complex number in standard form. Next, we need to find the modulus of 1 plus iota. Remember, the modulus of a complex number a plus b iota is square root of a square plus b square. So here a is 1 and b is 1 also. So the modulus is square root of 1 square plus 1 square, which is square root of 2. So first we know the modulus of a plus b iota equals modulus of a plus b iota equals square root of a square plus b square. Here a is 1 and b is also 1. So modulus of 1 plus iota equals square root of 1 square plus 1 square equal to square root of 1 plus 1, which is equal square root of 2. Therefore, the value of the modulus of z1 plus z2 plus 1 divided by z1 minus z2 plus 1 is square root of 2, and this is our final answer. I hope this question is clear to all of you. So now let's move to the next question. Now let's look at question number 6. First of all, see what has been given to you and what you have to do. So here in this question, we are given that a number a plus iota times b equals x plus iota whole square divided by 2x square plus 1, and then we have to prove that a square plus b square equals x square plus 1 whole square divided by 2x square plus 1 whole square. So first of all, think about this. How would you solve this question and then see solution? So now let's start the solution step by step. So first of all, see what we have given. So we are given a plus iota times b equals x plus iota whole square divided by 2x square plus 1. Now let's clarify what we need to prove. So the goal is to show that x square plus 1 whole square divided by 2x square plus 1 whole square, which is equals a square plus b square. Okay. So by taking the modulus of both sides of the equation, we get a plus iota. Here we taking the modulus of the both sides of the equation, a plus iota times b equals x plus iota whole square divided by 2x square plus 1. So this gives us the equation modulus value of a plus iota b equals a modulus value of x plus iota divided by 2x square plus 1. So first let's recall a key property of complex numbers. If we have a complex number z equals u plus iota times v, then modulus of z equals square root of a u square plus v square. Now let's remember some important properties of moduli. For any two complex numbers z1 and z2, the modulus of their product is modulus of z1 times z2 equals modulus of z1 times modulus of z2, and the modulus of their quotient is modulus of z1 divided by z2 equals modulus of z1 divided by modulus of z2. So these properties will help us simplify the expression we are working with. Now applying these properties to our problem, so we can write square root of a square plus b square equals absolute value of x plus iota whole square divided by absolute value of 2x square plus 1. Since 2x square plus 1 is a real number and for real x its value is positive, so its modulus is just itself. That means modulus of 2x square plus 1 equals 2x square plus 1. So this simplifies our calculation. So using the property modulus of z to the power n is equal to modulus of z raised to the power n. So square root of a square plus b square equals modulus of x plus iota whole square divided by 2x square plus 1. Now let's find the modulus of x plus iota. So using the formula of modulus of x plus iota is equal to square root of x square plus 1 square, which is equal to square root of x square plus 1. So this gives us the value we need for the numerator. Therefore, the modulus squared is modulus of x plus iota squared equal to square root of x square plus 1 whole square, which is equal to x square plus 1. Now let's substitute the value of the modulus squared of x plus iota, which is modulus of x plus iota whole squared equals x square plus 1 into our equation. So we know that the modulus of a complex number a plus iota times b is square root of a square plus b square. So we write square root of a square plus b square equals x square plus 1 divided by 2x square plus 1. Now let's square both sides of the equation to eliminate the square root. So this gives us square root of a square plus b square whole square equal to x square plus 1 divided by 2x square plus 1 whole square. After squaring, we get a square plus b square equals x square plus 1 whole square divided by 2x square plus 1 whole square. So we have successfully proved the identity. So I hope it is clear to all of you. So now let's move to the next question. In this question, first we have z1 equals 2 minus iota and z2 equals minus 2 plus iota, and then we have to find real part of z1 times z2 divided by z1 bar. Okay, so first of all, take a moment to think about how you would approach this calculation, okay, and how would you solve this question. So let's start the solution of this question. To start solving, let's write out what we are being asked. So we need to find the real part of z1 times z2 divided by the conjugate of z1. Okay, and we are given z1 equals 2 minus iota and z2 equals minus 2 plus iota. So we simplify the expression. So z1 times z2 equals 2 minus iota times minus 2 plus iota. Okay, and this is just like multiplying two binomials. So we will use the distributive property to expand this expression. So expanding the multiplication, we get 2 times negative 2 plus 2 times iota plus minus iota times minus 2 plus minus iota times iota. So that's our 4 separate terms. Let's simplify each term. So 2 times minus 2 will become minus 4. 2 times iota is 2 times iota. Okay, minus iota times minus 2 is 2 times iota, and minus iota times iota is minus iota square. Okay, so z1 times z2 will become minus 4 plus 2 iota plus 2 iota minus iota square. Now let's combine like terms. The two imaginary parts, 2 iota and 2 iota, add up to 4 times iota. For the last term, remember that iota squared is minus 1. So negative iota squared becomes negative of negative 1. Okay, which is basically this simplifies the expression. Okay, and then z1 times z2 will become minus 3 plus 4 times iota. So we have given z1 equals 2 times iota and its conjugate is z1 bar equals 2 plus iota. Okay, remember, to find the conjugate of a complex number a plus b times iota, we just change the sign of the imaginary part. So conjugate of a plus b iota is a minus b times iota. Okay, and here we use this concept and we found conjugate of z1 equals 2 plus iota. Now let's substitute the values we know. So we already have z1 times z2 equals minus 3 plus 4 times iota, and z1 bar equals 2 plus iota, and here we substitute these values into z1 times z2 divided by z1 bar. Okay, and rationalize the denominator. To rationalize, we multiply both the numerator and denominator by the conjugate of the denominator, which is 2 minus iota. Okay, so we have minus 3 plus 4 times iota over 2 plus iota. Okay, and after multiplying 2 minus iota in numerator and denominator, we get z1 times z2 divided by z1 bar equals minus 3 plus 4 times iota divided by 2 plus iota times 2 minus iota divided by 2 minus iota. Now let's expand the numerator and denominator. In the numerator, we multiply minus 3 times 2 minus 3 times minus iota. Okay, and then add them, plus 4 times iota times 2 plus 4 times iota times minus iota. Okay, and in the denominator we use 2 square minus iota square. Let's simplify those products. The numerator becomes minus 6 plus 3 times iota plus 8 times iota minus 4 times iota square, and the denominator is 4 minus of minus 1, since iota squared is negative 1. After simplifying, we get minus 2 plus 11 times iota divided by 5, which is equal to minus 2 over 5 plus 11 by 5 times iota. And this is the standard form a plus b times iota, where a is the real part and b is the imaginary part. So now let's see the solution. So the real part of z1 times z2 divided by conjugate of z1 is shown as real part of z1 times z2 divided by z1 conjugate equals minus 2 over 5. Okay, and this is our final answer. So I hope this question is clear to all of you. Now let's move to the next part. So now look at question number 7, second part. Okay, and in this question we are given z1 equals 2 minus iota and z2 equals minus 2 plus iota, and then we have to find imaginary part of 1 divided by z1 times z1 bar. So first of all, take a moment to think about this question. How would you approach this question? Okay, and then see the solution. So let's start the solution. To start solving this, let's focus on the denominator. Okay, that is z1 times its conjugate, written as z1 times conjugate of z1. Okay, so we first calculate the product z1 times z1 bar. Recall that z1 is given as 2 minus iota. Okay, and it's important to keep this form in mind as we work through the calculations. Okay, so we will use this value directly in the next step to find the product with its conjugate. And we know that for any complex number z times z bar equals modulus of z whole square. Okay, so let's recall how to find the modulus squared of a complex number. So if z equals x plus iota times y, then the modulus squared is x square plus y square. This means we square the real part and the imaginary part separately and then add them together. Now let's apply this to our specific value. For z1 equals 2 minus iota, the real part x is 2 and the imaginary part y is minus 1. So modulus of z1 whole square, that is z1 times z bar. Okay, so this is equal to a modulus of 2 minus iota square, which is equal to 2 square plus minus 1 whole square, which is equal to 4 plus 1 and which is 5. So therefore z1 times z1 bar equals 5. Now let's consider the reciprocal of z1 times its conjugate. So first recall that z1 is 2 minus iota, so its conjugate written as z1 bar, which is 2 plus iota. Okay, and here we have already found modulus of z1 square, which is 5. Okay, so we get 1 divided by modulus of z1 whole square equals 1 divided by 5. So notice that 1 by 5 is a purely real number. Okay, so in complex number form, any real number can be written as a plus b times iota, where b is 0. Okay, so 1 by 5 can be written as 1 by 5 plus 0 times iota. Okay, so this helps us clearly see the real and imaginary parts. Therefore the imaginary part of 1 by 5 is 0. Okay, since there is no iota term in 1 by 5, the coefficient of iota is 0. That's why we get the imaginary part of 1 divided by z1 times z bar equals 0. Therefore, imaginary part of 1 divided by z1 times z bar equals 0. So I hope this question is clear to all of you. So now let's move to the next question. So let's examine this question together. So we are asked to find the real numbers x and y such that the product x minus iota times 3 plus 5 times iota is the conjugate of minus 6 minus 24 times iota. Okay, remember iota is the imaginary part and the conjugate of a complex number a plus b times iota is a minus b times iota. So first of all, think about this. How would you approach this question? Then see the solution. So let's start the solution. So first, see what informations are given. So we are given that complex numbers x minus iota times y times 3 plus 5 times iota is the conjugate of minus 6 minus 24 times iota. And we need to find the real numbers x and y. So let's expand the product x minus iota times y times 3 plus 5 times iota. So multiplying out, we get x 3 times x plus 5x times iota minus 3 times y times iota minus 5 times iota square times y. Let's simplify further. So this expression will become 3x plus 5x times iota minus 3y times iota plus 5y, since iota square equals minus 1. Now combining like terms, the real part is now 3x plus 5y and the imaginary part is now 5x minus 3y. Okay, so x minus iota times y times 3 plus 5 times iota is equal to 3x plus 5y plus iota times 5x minus 3y. So the conjugate of minus 6 minus 24 times iota is minus 6 plus 24 times iota. So 3x plus 5y plus iota times 5x minus 3y equals minus 6 plus 24 times iota. Let's equate the real part of both sides. So the real part on the left side is 3x plus 5y and the real part of the on the right side is minus 6. Okay, so we have the equation 3x plus 5y equals minus 6. So this will be our first equation. Next, let's equate the imaginary parts. The imaginary part on the left is 5x minus 3y equals 24. So our second equation is 5x minus 3y equals 24. To solve these equations, let's eliminate y. So we will multiply equation 1, which is 3x plus 5y equals minus 6 by 3, and equation 2 by 2, which is 5x minus 3y equals 24 by 5. Okay, so to eliminate y, so multiplying equation 1 by 3 gives us 3 times 3x plus 5y equals 3 times minus 6, which simplifies to 9x plus 15y equals minus 18. So this is our new version of the first equation. Now multiplying equation 2 by 5 gives us 5 times 5x minus 3y equals 5 times 24, which simplifies to 25 times x minus 15y equals 120. This is our new version of the second equation. Let's add these two new equations together. So notice that terms with the y, 15y and minus 15y will cancel each other out and making it easier to solve for x. So we get 9x plus 15y plus 25x minus 15y equals minus 18 plus 120. Let's solve for x. We have 34 times x equals 102. So to isolate x, we will divide both sides by 34 and we obtain x equals 102 divided by 34. It implies x equals 3. Now substitute x equal 3 into the equation 3x plus 5y equals minus 6. So we write 3 times 3 plus 5 times y equals minus 6. Okay. Now let's simplify the equation. 3 times 3 is 9 and we have 9 plus 5 times y equals minus 6. So next we want to isolate the term with y. So we subtract 9 from both sides, giving us 5y equals minus 6 minus 9. It implies 5 times y equals minus 15. It implies y equals minus 3. Thus, the real numbers are x equals 3 and y equals minus 3. So I hope this question is clear to all of you and you are getting my point. So that's all for today's lecture and thank you very much to all of you.